Question number 10. In question number 10, it says the alpha level depends on the sample size. And the statement is false because the alpha level or significance level is a threshold that we decide. It does not depend on the sample size, but the p-value depends on the sample size. So question 11. So we want to compare two different neighborhoods and we want to see if they were built at roughly the same time. So we know we are comparing two groups. So we know we can do a hypothesis testing. So, and in this question, we need to find standard error, which is SE. We need to find the T, which is a test statistic. So let's use the StatCrunch to do this calculation to find those numbers. So because we are comparing two means, so we use the t-stats to sample with summary. Okay, because the data given to us are summary data. So for the first sample, the neighborhood 1, the sample mean is 54.5. So let's be careful about the notations. The y bar is the sample mean, small s is the sample standard deviation, and n is the sample size. So let's remember those notations. So the sample standard deviation is 7.11, sample size is 40, and for the second sample, the neighborhood 2, the sample mean is 45.3, and the sample standard deviation is 7.72, and sample size is 35. And then let's define our hypothesis. So in the null hypothesis, we assume that there's no difference. Okay, and in the alternative hypothesis, we assume that they are built at different times. Okay, so let's use not equal to because we just want to know if they were built at roughly the same time or not. So we use not equal to. Then let's click compute. Okay. Then for the first part A, we need to find the estimate the mean age difference. So it's a sample difference, which is given in here. The sample difference 9.2 goes there. So standard error. So standard error, we have that in the up window 1.72, and the t statistic or the test statistic is 5.34. Okay, we have all the numbers here. Okay. Then question number 12, we still deal with two groups, and in this time we are going to construct the confidence interval. Okay. So let's see, open the, let me close this first, and let's click StatCrunch, and we still go to t-stats to sample with summary because we are given the summary data. Okay, so sample mean 6.2, sample standard deviation 4.6, and sample size 90. Okay, and the sample mean is for the second group is 6.1, standard deviation is 4.3, and sample size is 95. Okay, and now we are doing a confidence interval for the mean difference. Okay, so let's select this confidence interval option, and the confidence level is 95%, and here the default value is 0.95, so we don't have to change. Let's click compute. Okay, then we got the lower limit and upper limit. We put those numbers in there. Okay, and part B, why is the confidence interval narrower than the one that we are given another confidence interval, and this interval is wider than the one we calculated. So this new one is based on 5 randomly sampled because the reason is the sample sizes are larger. Okay? Because we know the confidence interval is equal to the estimate plus minus the margin of error, and the margin of error is equal to the critical value times standard error, and standard error depends on the sample size. Okay, so if we review the expression for the sample size in chapter 12, so we know the samples, if we have a larger sample size, the standard error would be smaller. So that means the confidence interval will be narrower. So that's why the one we calculated is narrower than the one that is given us in this question. Okay, so that's why that's the reason the sample sizes are larger. And if 0 in the confidence interval, yes, 0 is in there. And what does the confidence interval suggest about the null hypothesis? Because the null hypothesis, in the null hypothesis, we assume that the mu1 minus mu2 is equal to 0. Okay, and this 0 is in the confidence interval. That means 0 could be a possible value for the true difference. Okay, so that's why it suggests that we fail to reject the null hypothesis because 0 is plausible value for the true mean difference because 0 is in the confidence interval.